Hey everyone, my name is Trent Kelly, and this is my first attempt at D207 Exploratory Data Analysis. And my table of contents are going to be with A, describe a real-world organizational situation or issue in the data dictionary you choose. And we'll dive into that more later. Describe the data analysis by doing the following techniques, which we will get into. C, identify the distribution of two continuous variables and two categorical variables, including univariate statistics from your cleaned and prepared data. This is for C and D. And E, summarize the implications of your data analysis by doing the following, and we will look into that. And then G and H are going over the sources and citations. All right, with A, describe a real-world organizational situation or issue in the data dictionary. Provide one question that is relevant to your chosen data set. So what I wanted to look at is the relationship between the level of education and readmissions, since the data dictionary did place an emphasis on penalties imposed on readmissions. So my null hypothesis is going to be the level of readmissions will be lower when compared to those with higher education levels, and my alternative will be that they are in fact higher. And my p-value is going to be if less than 0.5%, I reject my null and accept my alternative. If greater than 0.05%, that will support my null hypothesis. A2, explain how stakeholders in an organization could benefit from an analysis of the data. And so from the data dictionary, it discusses the penalties that are imposed by CMS and the amount of readmissions, and as much as 78% of hospitals were fined in the fiscal year of 2015. So I wanted to evaluate just a couple of variables, and I've been using this kind of question with D, I think all the way back to D205 and D206. And so I just wanted to see if there's any sort of correlative relationship between a level of education and readmissions. Maybe there's an educational opportunity there that, because reading levels can vary wildly. And so I just wanted to see if, we had lower rates of readmission the more educated people become, or, is it higher the lower education that they've received. Just wanted to see if there was something that I could deduce from the educational versus readmission data we had. And so this would be a benefit, because if we could tie some correlation to those two, we could begin to dive into what that looks like, maybe look at how our discharge instructions are worded, maybe lower them to a lower reading level, just to see if there's something we can change with the readmission rates and thus change our readmission rates. Identify all of the data that I'm using. So I'm just using the education and readmissions. Both columns are qualitative, which we will verify later. B1, using one of the following techniques, write code in Python or R to run analysis on the data set. So since we know that these are qualitative, which we will verify later, we have to use the chi-square. And as tests if there are significant associations between two categorical variables. And these are the libraries that I will be using. And this is my clean data set from D206. And this is where it's coming from. And so anytime I import any CSV files, I want to make sure that it's the correct one, especially when I'm using clean versus original data sets. So I know that this is a clean because these are renamed. And with the original data set, these were item 1 through 8. So yes, that's the one I need. And to look and verify that what I've chosen are categorical or qualitative, I'm reusing code from D206. I just took out the line of code that is going over or pulling out just an example from each rows or columns rather, not rows. And so I'm just looking specifically at education and readmissions. I'm creating my new data frame, B_DF, and I'm naming them, and the or that's going to be on the name data type. And then just looking at quantitative versus qualitative. And so, yes, we do indeed see that those are both qualitative in nature. All right, and so I've never done this test before, so I did pull the code direct from DataCamp. And so what we're doing is we're creating this cross table, and we're looking at education and readmissions. And so we have our education level and no and yes counts. And then looking at our actual test, again, comparing education to readmissions, and we're going to get a few metrics from this. So we're going to get our statistics, p-value, degrees of freedom, and expected frequency. And I just looked at the p-value specifically, just so I had it, and it's 0.175, rounded it to 0.18. So with that being my p-value, it is indeed greater than 0.05. So I do not have sufficient evidence to reject my null hypothesis. This also indicates that our null hypothesis could occur by chance alone. That's a problem. And there's not enough evidence to suggest a significant association of or relationship between the variables. So why have I chosen this analysis technique? With the two that we selected, those are qualitative in nature, so I have to use the chi-square test. The other two require quantitative. C1, identify the distribution of two continuous variables and two categorical variables using univariate statistics from your cleaned and prepared data. So categorical variables, according to the DataCamp, univariate plots only display one variable for analyzing the distribution of that variable. And the examples that they provided were bar, histogram, box plot, density plot. So it's just providing a definition of what univariate plots are, what they do. So they're looking at one variable. And according to Code Academy, it's just listing out what categorical variables consist of, and that they can be ordinal or nominal. And all that means is that ordinal is going to have some predefined hierarchy of value. The description or example is on a scale from 1 to 7, how happy are you right now? So 1 to 7, each one of those is numerically important in that question or answer. A nominal, there is no hierarchy. It's just essentially an answer. Like people's hair color, what is your education level? It's not ranking the education level, just giving you what it is. And so based on the description, I would say education and readmission would both be nominal categorical variables. They do not require rankings. And so this is plotting it out. So pulling the education column from the, that is actually supposed to be, I had my clean data set from D206, and then my code just for creating it. So we're just looking at education counts and the values. And this marker doesn't have to be there, but it just helped me. That is the circles, and that just tells me where this is plotting out as. You don't have to have that. And so for readmissions, the same thing, except for this is just going to be a bar chart and telling us the amount of no's versus yeses. D1, identify the distribution of two continuous variables and two categorical variables. So this is the continuous variables, and those are described as quantitative variables are numeric in nature and can be either continuous or discrete. Continuous variables contain measurements with decimal precision, and discrete variables contain counts that must be whole integer values. And so for the two that I selected, income and age, they are represented as decimals or go out to decimals. So these would be two continuous variables. Both are represented out to the decimal level and numerical and are numerical quantitative. Looking at the density, kernel density estimation, this is just an estimation of the underlying probability density function of a continuous variable. So that's where it's showing the highest density for income. And then for age, shows us that we have a lot of age 50, and that is really high, comparatively speaking to the other age groups. So maybe there's something there we could look at. E1, summarize the implications of your data analysis by doing the following. So discuss the results of the hypothesis test. So my null hypothesis, the level of readmissions will be lower when compared to those with higher levels because of our p-value. I don't have sufficient evidence to reject the null hypothesis. However, this association could have happened purely by chance. So that's a problem. And then I was just looking at numerically, what these look like, after I put this down. So just counting the number of occurrences of each unique response in the unique or education column. So I could just look at it and summarize the implications and discuss the limitations of your data analysis. So I did create two additional kind of metrics to look at to help answer this question. From this, I realized that my approach and experiment or hypothesis was flawed, especially with the data set that's given. And what I would propose is potentially restarting this analysis and looking at individual education levels versus the entire data set of education levels. And the reason being is because we have I would say a large contrast in the amount that's represented. So with high school diploma, we have a lot of data. And with, say, doctorate degrees or no schooling completed and professional school degree, we don't have a lot of data. So I would propose that we pull individual columns out and assess them for further use. And, I would say with regular high school diploma, since that's where we have the largest data set, that's where I would probably start. And the other questions I had when looking at this, especially graphed out like this, is ideally speaking, from a experiment standpoint, we would have all things would be constant. So we would have the exact same amount of answers for all of these. So we can look at the yes and no's. And then at that point, I would say we could use this sort of approach that if we had the same amount, and we could potentially normalize the data and, scale it way down to the doctorate degrees, the ones that are on the lower level. But when we look at doctorate degrees, let's see, what do we have? 60, 94 responses. So that's taking over 2,000 from, like regular high school, scaling it way down. So I wouldn't say that that's valuable. But if we could get a normal amount across the board, or equal amount rather, across the board of degrees, and look at that, have a sufficient study group of the doctorate degrees, which that may be challenging because I can't imagine that too many people have doctorate degrees in perspective to or related to the high school diplomas. More people are just going to have high school diplomas, so the data collection opportunity we have there is going to be much higher for high school diploma because most of the population is going to have high school diploma. So that would be something to explore further, potentially ask some better or different questions. Recommend a course of action based on your results. So kind of like I just talked about, I would potentially reframe this, re-experiment, see if we can get more data. If not, look at these individually and see if there's something we can do with high school diploma. But we have the next runner-up is bachelor's degree, and I would consider that a decently educated person. So maybe look at these individually. And so, looking at the results, those with high school diplomas are much more likely to A, walk into a hospital, or B, readmit once they've, walked in. But these numbers are kind of skewed as far as the readmittance, because that's what we have the largest data set on. If we scale the data back, we're reducing it to very small amounts, and I don't think that's fair to the question. And I don't think it's going to be very valuable. And this isn't necessarily beneficial to the company, but I would say overall, being humanitarian, that we notice that no school completed is very small. So either A, people don't want to say that they don't have an education completed. B, there's not very many, which would say that we have a robust educational system in America, which I would argue. Or C, there may be some financial implications with this, which we could explore to see if there's a financial implication with schooling, what the reported income is with this group, and then maybe report that to the local municipalities that, hey, this is what we're getting in our hospital level. Do you have any infrastructure to provide universal care to those that may not have the education or income? Let's see. And yeah, it looks like that's all I have. So here's my references. I did use some DataCamp code. So that is represented in here. And I appreciate your time, and I look forward to your feedback.